So GPT-4 is a pretty substantial improvement on top of ChatGPT across very many dimensions. We trained GPT-4, I would say, between more than 6 months ago, maybe 8 months ago, I don't remember exactly. The first big difference between ChatGPT and GPT-4, and that perhaps is the most important difference, is that the base on top of GPT-4 is built predicts the next word with greater accuracy. This is really important because the better a neural network can predict the next word in text, the more it understands it. This claim is now perhaps accepted by many at this point, but it might still not be intuitive, or not completely intuitive as to why that is. So I'd like to take a small detour and to give an analogy that will hopefully clarify why more accurate prediction of the next word leads to more understanding, real understanding. Let's consider an example. Say you read a detective novel. It's like a complicated plot, a storyline, different characters, lots of events, mysteries like clues, it's unclear. Then, let's say that at the last page of the book, the detective has gathered all the clues, gathered all the people, and saying, okay, I'm going to reveal the identity of whoever committed the crime. And that person's name is...
Predict that word.
Predict that word,
Yeah,
exactly.
my goodness.
Right?
Yeah, right.
Now, there are many different words, but by predicting those words better and better and better, the understanding of the text keeps on increasing. GPT-4 predicts the next word better.
You know, Ilya, people say that deep learning won't lead to reasoning, that deep learning won't lead to reasoning. But in order to predict that next word, figure out from all of the agents that were there and all of their, strengths or weaknesses or their intentions and the context, and to be able to predict that word, who was the murderer, that requires some amount of reasoning, a fair amount of reasoning. And so how is it that it's able to learn reasoning, and if it learned reasoning, one of the things that I was going to ask you is, of all the tests that were taken between ChatGPT and GPT-4, there were some tests that GPT-3 or ChatGPT was already very good at. There were some tests that GPT-3 or ChatGPT was not as good at, that GPT-4 was much better at. And there were some tests that neither are good at yet. I would love for it, and some of it has to do with reasoning, it seems. That, maybe in calculus that it wasn't able to break maybe the problem down into its reasonable steps and solve it. But yet in some areas, it seems to demonstrate reasoning skills. And so is that an area that in predicting the next word, you're learning reasoning? And what are the limitations now of GPT-4 that would enhance its ability to reason even further?
Reasoning isn't this super well-defined concept, but we can try to define it anyway, which is when you maybe when you go further, where you're able to somehow think about it a little bit and get a better answer because of your reasoning. And I'd say that our neural nets, maybe there is some kind of limitation which could be addressed by, for example, asking the neural network to think out loud. This has proven to be extremely effective for reasoning. But I think it also remains to be seen just how far the basic neural network will go. I think we have yet to fully tap out its potential. But yeah, there is definitely some sense where reasoning is still not quite at that level as some of the other capabilities of the neural network, though we would like the reasoning capabilities of the neural network to be higher. I think that it's fairly likely that business as usual will improve the reasoning capabilities of the neural network. I wouldn't necessarily confidently rule out this possibility.
Yeah, because one of the things that is really cool is you ask ChatGPT a question, but before it answers the question, tell me first of what you know, and then to answer the question. Usually when somebody answers a question, if you give me the foundational knowledge that you have or the foundational assumptions that you're making before you answer the question, that really improves my believability of the answer. You're also demonstrating some level of reason. Well, you're demonstrating reasoning. And so it seems to me that ChatGPT has this inherent capability embedded in it. Yeah.
To some degree.
Yeah.
One way to think about what's happening now is that these neural networks have a lot of these capabilities. They're just not quite very reliable. In fact, you could say that reliability is currently the single biggest obstacle for these neural networks being useful, truly useful. If sometimes it is still the case that these neural networks hallucinate a little bit, or maybe make some mistakes which are unexpected, which you wouldn't expect a person to make. It is this kind of unreliability that makes them substantially less useful. But I think that perhaps with a little bit more research, with the current ideas that we have, and perhaps a few more of the ambitious research plans, we'll be able to achieve higher reliability as well. And that will be truly useful. That will allow us to have very accurate guardrails, which are very precise.
That's right.
And it will make it ask for clarification where it's unsure, or maybe say that it doesn't know something when it doesn't know, and do so extremely reliably. So I'd say that these are some of the bottlenecks, really. So it's not about whether it exhibits some particular capability, but more how reliably.
To the degree
exactly.
Of it, yeah. One is speaking of factualness and factfulness, hallucination. I saw in one of the videos a demonstration that links to a Wikipedia page does retrieval capability. Has that been included in the GPT-4? Is it able to retrieve information from a factful place that could augment its response to you?
So the current GPT-4, as released, does not have a built-in retrieval capability. It is just a really, really good next word predictor, which can also consume images, by the way. We haven't spoken about it, but
I'm about to ask you about multimodality.
It is really good at images, which is also then fine-tuned with data and various reinforcement learning variants to behave in a particular way. It is perhaps, I'm sure someone will, it wouldn't surprise me if some of the people who have access could perhaps request GPT-4 to maybe make some queries and then populate the results inside the context. Because also the context duration of GPT-4 is quite a bit longer now.
Yeah, that's right.
So, in short, although GPT-4 does not support built-in retrieval, it is completely correct that it will get better with retrieval.
Multimodality. GPT-4 has the ability to learn from text and images and respond to input from text and images. First of all, the foundation of multimodality learning, of course, Transformers has made it possible for us to learn from multimodality. You tokenize text and images. But at the foundational level, help us understand how multimodality enhances the understanding of the world beyond text by itself. And my understanding is that when you do multimodality learning, that even when it is just a text prompt, the text understanding could actually be enhanced. Tell us about multimodality at the foundation, why it's so important, and what was the major breakthrough and the characteristic differences as a result?
So there are two dimensions to multimodality. two reasons why it is interesting. The first reason is a little bit humble. The first reason is that multimodality is useful. It is useful for a neural network to see. Vision in particular, because the world is very visual. Human beings are very visual animals. I believe that a third of the human cortex is dedicated to vision. And so, by not having vision, the usefulness of our neural networks, though still considerable, is not as big as it could be.
Mm-hmm.
So it is a very simple usefulness argument.
Mm-hmm.
It is simply useful to see. And GPT-4 can see quite well. There is a second reason to do vision, which is that we learn more about the world by learning from images in addition to learning from text. That is also a powerful argument, though it is not as clear-cut as it may seem. And I'll give you an example. Or rather, before giving an example, I'll make the general comment. For a human being, us human beings, we get to hear about 1 billion words in our entire life.
Only?
Only 1 billion words.
That's amazing. Yeah.
That's not a lot.
Yeah, that's not a lot.
So we need to compensate.
Does that include my own words in my own head?
Make it 2 billion words if you want. But you see what I mean.
Yeah.
You know, we can see that because 1 billion seconds is 30 years. So you can kind of see, like, we don't get to see more than a few words a second, and then we are asleep half the time.
Yeah.
So like a couple billion words is the total we get in our entire life.
Mm-hmm.
So it becomes really important for us to get as many sources of information as we can. And we absolutely learn a lot more from vision. The same argument holds true for our neural networks as well, except for the fact that the neural network can learn from so many words. So things which are hard to learn about the world from text in a few billion words may become easier from trillions of words. And I'll give you an example. Consider colors. Surely one needs to see to understand colors. And yet, the text-only neural networks who've never seen a single photon in their entire life, if you ask them which colors are more similar to each other, it will know that red is more similar to orange than to blue.
Mm-hmm. Mm-hmm.
It will know that blue is more similar to purple than to yellow.
Mm-hmm.
How does that happen? And one answer is that information about the world, even the visual information, slowly leaks in through text, but slowly, not as quickly. But when you have a lot of text, you can still learn a lot. Of course, once you also add vision and learning about the world from vision, you will learn additional things which are not captured in text.
Mm-hmm.
But it is not, I would not say that it is a binary. There are things which are impossible to learn from text only. I think this is more of an exchange rate.
Yeah.
And in particular, as you want to learn, if you are like a human being and you want to learn from 1 billion words or 100 million words, then of course the other sources of information become far more important.
Yeah, and so the you learn from images. Is there a sensibility that would suggest that if we wanted to understand also the construction of the world, as in, you know, the arm is connected to my shoulder, that my elbow is connected, that somehow these things move, the animation of the world, the physics of the world. If I wanted to learn that as well, can I just watch videos and learn that?
Yes.
Yeah. And if I wanted to augment all of that with sound, like for example, if somebody said the meaning of great, great could be great, or great could be great, you know. So one is sarcastic, one is enthusiastic. There are many words like that, you know. That's sick, or, you know, I'm sick, or I'm sick. Depending on how people say it, would audio also make a contribution to the learning of the model, and could we put that to good use soon?
Yes.
Yeah.
I think it's definitely the case that, well, what can we say about audio? It's useful. It's an additional source of information. Probably not as much as images or video, but there is a case to be made for the usefulness of audio as well, both on the recognition side and on the production side.
When you on the context of the scores that I saw, the thing that was really interesting was the data that you guys published. Which one of the tests were performed well by GPT-3, and which one of the tests performed substantially better with GPT-4? How did multimodality contribute to those tests, do you think?
Oh, I mean, in a pretty straightforward way, anytime there was a test where a problem where to understand the problem, you need to look at a diagram. Like, for example, in some math competitions, like there is a math competition for high school students called AMC12, right? Yeah. And there, presumably, many of the problems have a diagram. So GPT 3.5 does quite badly on that test. GPT-4 with text only does, I don't remember, but it's like maybe from 2% to 20% accuracy of success rate. But then when you add vision, it jumps to 40% success rate. So the vision is really doing a lot of work. The vision is extremely good. And I think being able to reason visually as well and communicate visually will also be very powerful and very nice things, which go beyond just learning about the world. You have several things. You can learn about the world. You can then reason about the world visually. And you can communicate visually. Where now, in the future, perhaps, in some future version, if you ask your neural net, hey, like, explain this to me, rather than just producing 4 paragraphs, it will produce, hey, like, here's like a little diagram which clearly conveys to you exactly what you need to know, and so on.
That's incredible. One of the things that you said earlier about an AI generating tests to train another AI, there was a paper that was written about, and I don't completely know whether it's factual or not, but that there's a total amount of somewhere between 4 trillion to something like 20 trillion useful, tokens in language tokens that the world will be able to train on, over some period of time, and that we're going to run out of tokens to train. And well, first of all, I wonder if that you feel the same way, and then secondarily, whether the AI generating its own data could be used to train the AI itself, which you could argue is a little circular, but we train our brain with generated data all the time by self-reflection, working through a problem in our brain, or some, I guess neuroscientists suggest sleeping. We do a fair amount of developing our neurons. How do you see this area of synthetic data generation? Is that going to be an important part of the future of training AI and the AI teaching itself?
Well, I think, like, I wouldn't underestimate the data that exists out there. I think there's probably more data than people realize. And as to your second question, certainly a possibility. Remains to be seen. Yeah,
it really does seem that one of these days our AIs are when we're not using it, maybe generating either adversarial content for itself to learn from, or imagine solving problems that it can go off and then improve itself. Tell us whatever you can about where we are now and where do you think we'll be in not too distant future, but pick your horizon, a year or two. Where do you think this whole language model area would be in some of the areas that you're most excited about?
Predictions are hard, and it's a bit, although it's a little difficult to say things which are too specific, I think it's safe to assume that progress will continue, and that we will keep on seeing systems which astound us in the things that they can do. And the current frontiers will be centered around reliability, around the system can be trusted, really get into a point where we can trust what it produces. Really get into a point where if it doesn't understand something, it asks for a clarification, says that it doesn't know something, says that it needs more information. I think those are perhaps the areas where improvement will lead to the biggest impact on the usefulness of those systems. Because right now, that's really what stands in the way. You ask a neural net to maybe summarize some long document, and you get a summary. Like, are you sure that some important detail wasn't omitted? It's still a useful summary, but it's a different story when you know that all the important points have been covered. At some point, and in particular, it's okay, even there is ambiguity, it's fine, but if a point is clearly important, such that anyone else who saw that point would say, this is really important, when the neural network will also recognize that reliably, that's when you know. Same for the guardrail, same for its ability to clearly follow the intent of the user, of its operator. So I think we'll see a lot of that in the next 2 years.
Yeah, that's terrific, because the progress in those two areas will make this technology trusted by people to use and be able to apply for so many things. I was thinking that was going to be the last question, but I did have another one. Sorry about that.
Okay, go for it.
So ChatGPT to GPT4. GPT4, when you first started using it, what are some of the skills that it demonstrated that surprised even you?
Well, there were lots of really cool things that it demonstrated, which were quite cool and surprising. It was quite good. So I'll mention two so let's see. I'm just trying to think about the best way to go about it. The short answer is that the level of its reliability was surprising. Where the previous neural networks, if you ask them a question, sometimes they might misunderstand something in a kind of a silly way. Whereas with GPT-4, that stopped happening. Its ability to solve math problems became far greater. It's like you could really really do the derivation and long, complicated derivation, and you could convert the units and so on. And that was really cool. Many people
it works through a proof. It works through a proof. I mean, it's pretty amazing.
Not all proofs, naturally, but quite a few.
Yeah.
Or another example would be, many people noticed that it has the ability to produce poems with, every word starting with the same letter, or every word starting with some...
It follows instructions really, really clearly.
Not perfectly still, but much better than before.
Yeah, really good.
And on the vision side, I really love how it can explain jokes, it can explain memes. You show it a meme and ask it why it's funny, and it will tell you, and it will be correct. The vision part, I think, it's really actually seeing it when you can ask follow-up questions about some complicated image with a complicated diagram and get an explanation. That's really cool. But yeah, overall, I will say, to take a step back, I've been in this business for quite some time, actually, almost exactly 20 years. And the thing which I find most surprising is that it actually works.
Yeah.
It turned out to be the same little thing all along, which is no longer little and is a lot more serious and much more intense. But it's the same neural network, just larger, trained on maybe larger data sets in different ways, with the same fundamental training algorithm.
Yeah.
So it's wow. I would say this is what I find the most surprising.
Yeah.
Whenever I take a step back, I go, how is it possible that those ideas, those conceptual ideas about, the brain has neurons, so maybe artificial neurons are just as good. And so maybe we just need to train them somehow with some learning algorithm, that those arguments turned out to be so incredibly correct. That would be the biggest surprise, I'd say.
In the 10 years that we've known each other, the models that you've trained and the amount of data you've trained from what you did on AlexNet to now is about 1 million times, and no one in the world of computer science would have believed that the amount of computation that was done in that 10 years time would be 1 million times larger, and that you dedicated your career to go do that. You've done many more. Your body of work is incredible, but 2 seminal works, and the co-invention with AlexNet, and that early work, and now with GPT at OpenAI, it is truly remarkable what you've accomplished. It's great to catch up with you again, Ilya, my good friend, and it is quite an amazing moment. And today's talk, the way you break down the problem and describe it, this is one of the best PhD, beyond PhD descriptions of the state of the art of large language models. I really appreciate that. It's great to see you. Congratulations.
Thank you so much.
Yeah, thank you.
I had so much fun.
Thank you.